Does your child have gut dysbiosis? Has improving their gut improved other symptoms as well? Is there science to back that? Hi, I'm Dr. Theresa Lyons. I teach parents the cutting-edge science of autism so that you can make the best decision for your child based on quality information. Welcome to my video series on microglia. In this video, we will explore the microbiota and microglia. There is now compelling scientific data suggesting that the intestinal microbiota can play a causative role in driving the behavioral changes associated with autism. That is a direct quote from a scientific paper. Gut dysbiosis is common in those with autism, but interesting therapies targeting the microbiome can markedly improve or completely remediate behavioral symptoms. The interplay between the gut microbiota and the brain cells called microglia is important to understand. Come learn about the microglia so that you have up-to-date information. Let me get my slides so you can see what I'm talking about. If you find this video to be helpful, please hit the like button and also subscribe to my channel to get the cutting-edge scientific information about autism so that you can make the best decision for your child based on quality information.
Microglia, microbiota, and autism. All right, just a warning here. This is an advanced topic. This information is very useful after beginning steps have been taken in the autism journey. There are many beginner steps to take, and doing advanced steps early usually doesn't make the impact that one might be seeking. You can certainly watch this video and learn what could be possible in the future, but if you haven't done basic steps, focus on those. Microglia. Microglia plays several fundamental roles in orchestrating brain development and homeostasis. If you want to learn some of the basics about microglia and autism, I do have a video, it'll be linked below, about the basics of microglia. The one point to really remember about microglia is that they are highly sensitive to environmental cues. Autism in the gut. Research studies have shown that the intestinal microbiota can play a causative role in driving the behavioral changes associated with autism. If you or your child has had autism for a while, I'm sure this is nothing new, but I want to make sure we cover some of the foundations. Not only is intestinal dysbiosis commonly reported in those with autism, but therapies targeting the microbiome can markedly alleviate behavioral symptoms. This is why probiotics has certainly become quite popular. But it's not as simple as just taking a probiotic. There's a lot of synergy involved in optimal health. Let's understand the reciprocal interactions between microglia and intestinal microbes that could play a crucial role in autism. And I say reciprocal. So there's a two-way communication between microglia and intestinal microbiota. Microglia and autism. Several studies show that autistic individuals have ongoing neuroinflammatory health issues characterized by microglia activation in certain discrete regions of the brain. So what that says is not everyone with autism has issues with microglia, and not everyone with autism who have issues with microglia would have it in the same region of the brain. So this is where some people say autism can get really complex. It's because it's not homogeneous, right? So everyone doesn't experience neuroinflammation the same way. That really shouldn't come much of a surprise, but anyway, some dispute the significance of this and suggest that microglia may be intrinsically dysfunctional. So there's controversy, and as scientific theories develop, there's always controversy. That's how they develop into the best theory possible. The question to ask yourself and then a well-trained doctor is, does my child have neuroinflammation? If they don't, right, and you want to measure it, you want to work with a doctor who can actually answer that question with truth and with lab results, then this is not something to be concerned about. But if your child does have neuroinflammation, as many do, then this is where you want to start getting more and more granular. Microglia and autism, it's in the early stages of understanding. So there's not a full consensus yet. There's still debate. There's still different research studies going on to really understand this topic. In 2005, that's when the first scientific article was published showing an inflammatory phenotype, that just means you could see it physically, in postmortem brains from those with autism. So that's only in 2005. In that research, it showed that increased microglia activation was present. It was also present with increased inflammatory markers in both the brain and the cerebrospinal fluid. I do have 2 videos on cerebrospinal fluid and autism research, so the links will be down below if you want to learn about cerebrospinal fluid. Again, that is cutting edge research. All that I'm talking here is new research within the past decade or so. Neuroinflammation is real. I know on social media and Facebook, and there's so many just buzzwords, and I don't know, people use words that I don't think maybe they even know what it is, but neuroinflammation is real. Other research studies have reported increased neuroinflammation in postmortem brain tissue and cerebrospinal fluid of children with autism, suggesting a heightened immune response with associated localized brain inflammation. So once again, neuroinflammation is real. And the characterization that the scientists were able to do is they looked at TNF-alpha and several different interleukins. So it's not just this broad blanket statement, oh, there's neuroinflammation. No, you can actually quantify the neuroinflammation if you're looking at these different markers. Autism and the gut. GI dysfunction is one of the most prominent comorbidities in those with autism. And that's things like abdominal discomfort, irritated bowel syndrome, chronic diarrhea, and/or constipation, and the list can go on and on. Variations in the composition and diversity of the gut microbiota in those with autism have been observed to be different compared to neurotypical controls. So we know the gut composition in those with autism is different. I don't believe this is disputed anymore in the scientific community. Microglia and autism. Microglia are highly sensitive to environmental changes, right? That was the one thing to remember in this video about microglia. Microglia are highly sensitive to environmental changes, not just locally in the brain, but throughout the body. The body is connected. On the most basic level, microglia are readily activated in response to systemic inflammation. So if there's inflammation going on somewhere else in the body and the microglia can sense it, they're going to be activated. If the cause is great enough, so if this systemic inflammation is ongoing and let's say it's increasing, it can actually trigger the activation of microglia in the brain. So this is a really important point to remember, that if the systemic inflammation is great enough, then that can trigger the activation of microglia in the brain. While the gut microbiota will not induce systemic inflammation if a person has a healthy, optimally functioning gut, it has been well documented that autism is associated with barrier defects in the GI tract. This is what's often referred to as leaky gut. Scientists hate that term, leaky gut, but that's the buzzword in mainstream media. And those with autism also have impaired blood-brain barrier integrity. So if someone has a healthy, optimally functioning gut, and let's say there's some type of inflammation within the gut, typically the microglia would not be activated in that instance because their gut is functioning and it will contain it. However, those with autism often have intestinal permeability issues. That's the way scientists like to say leaky gut, as well as impaired blood-brain barrier. And so the inflammation that is going on in the gut can actually spread outside the gut. And then that is what can trigger the microglia to activate. Here's a quote from the research article. Thus, it is possible that inappropriate trafficking of bacterial cell wall components through the intestinal barrier to the central nervous system through a permissive blood-brain barrier could contribute to abnormal microglia activation and associated neurological symptoms. Microglia can sense peripheral changes in more subtle ways, and it is becoming increasingly apparent that they respond to changes in the gut microbiotic composition, even though the gut is quite far away from the brain. Gut disruptions can be sensed by brain cells. The gut microbiota can influence both microglia maturation and activation. Here's a figure from that research article in case someone wanted to have a little more visual learning. This is your, I don't know about normal neurodevelopment. I would say an optimally functioning gut. And this is over here in the autism spectrum. And so what could potentially be happening? And again, this is the reference. Conclusion. Although it is yet to be fully established, a causal relationship between immune dysfunction, dysbiosis, and the barrier defects associated with autism patients seems likely, and we propose this as a major factor in the maintenance of neurological dysfunction in autism. And here are your references.